questions on the chapter Introduction to Physics, or you can also call it as units and dimensions. So the first question is, calculate the dimensional formula of the energy from the equation E equals to half mv square. That is the formula of kinetic energy. So dimensionally E equals to m into v square. Since 1 by 2 is a number, so have no dimensions. So E equals to m L square t minus 2. So ml square t minus 2 is the dimension of energy, that is ml square t minus 2. Now question number 2 is test. So test dimensionally if the formula of tan of time equals to 2 pi under root m by f by x may be correct, where t is the time period, m is equal to mass, and f equals to force, and x is the distance. So dimensionally, first of all, we have solved the LHS equals to RHS for proving the equation may be true. So LHS equals to t, that is t, and now the turn of RHS, since 2 pi is a numerical value, so it has no dimension. So m by force is equal to mass into ml t minus 2, and that is divided by x, that is distance, so it will be written above like this. So L cancel, m cancel, so t square, that is t. Since LHS equals to RHS, so the equation may be correct. Now we will take the help of the book for reading the question and solve this in the text copy, or in which worked out examples we have to solve. First question is dimensional formula of the following quantities, that is the universal gravitational constant. So first, the universal constant of gravitation g का डायमेंशन निकालना है, but the formula is given here, that is f equals to g m1 m2 by r square. So we know that. So f equals to f into r square by m1, r square into m1 into m2 equals to g. So putting the dimension of force, ml t minus 2, length l square, mass m square. So dimension of g equals to m minus 1 l 3 t minus 2 m minus 1 l 3 t minus 2. Second, the surface tension formula dimensionally, whose formula is given there, that is S equals to grh by 2. So dimension of S equals to, its dimension will be mlq multiplied by g, that is l by t square, and r and h, that is length square. So m l cancel out, mt minus 2 is the dimension of the surface tension formula. Now third question, that is the thermal conductivity K, whose formula is given here, that is Q equals to K a theta 2 minus theta 1 into T by D. So here Q is the heat energy having, whose dimension is ml square t minus 2, where K has no dimension. We have to find that. A is the area, L square theta, and is the temperature. So its dimension will be Kelvin, temperature T, and distance L. So we can say that T minus 2 pi will be cancelled out, so L K T is equals to K. So dimension of K equals to, that is thermal conductivity, M L1 T minus 3 and K minus 1, M L1 T minus 3 and K minus 1 is the dimension of thermal conductivity. Now fourth is the coefficient of viscosity, and that is coefficient of viscosity and where formula is minus Na V2 minus V1 by x2 minus x1. So force dimension is M L T minus 2 and dimension will be given by this. So we have to take this in the denominator of the LHS side. So velocity minus velocity will be velocity, that is LT minus 1, and distance will be multiplied over, that is x L square, and area will be, this will be L and this will be L square. So this will be cancel out. So M का dimension equals to ML minus 1 T1, ML minus 1 T minus 1, since minus 1 plus 1 equals to minus 1. Answer. Now we will move on to question number 2, that is dimensional formula of first charge Q, where Q equals to IT. So dimension of Q equals to IT का dimension B is potential, that is V, and his formula is U equals to VIT. So U is the ml square T minus 2, that is the energy, that is ml square T minus 2. We have to find V. IT is the given above, that is INT. So V equals to ml square T minus 3 I minus 1, ml square T minus 3 and I minus 1. You can also write in this way, ml square T square I minus 1 T minus 3, or in this way both. As some books have written this because of making the alphabetical order. And now the third one is capacitance, that is C, whose formula is Q equals to CV, where Q is the charge, that is Q above, IT function dimension, and V dimension is ml square I minus 1 or T minus 3. So C dimension will be, this will be the denominator, so m minus 1, L minus 2, I will be minus and I 2, and T will be 4, that is m minus 1 L2 L minus 2 T I2 T4. Now fourth will be of resistance R, whose formula is V equals to Ri. So we have seen that the dimension of B is ml square I minus 1 T minus 3, and R equals dimension of R by dimension of I in the LHS side. So I equals to I. So R dimension will be ml square I minus 2 T minus 3, ml square I minus 2 T minus 3. So we will go on to the third question. Answer, that is here. The SI unit of energy is given that joule, and CGS unit of energy is erg. So we have to find that 1 joule equals to how many erg. So we can find this by the method energy equals to mass into velocity square, that is its dimension will be ml square t minus 2. So 1 joule equals to 1 kg per 1 centimeter is 1 meter square, and 1 second minus 2, and 1 hour can be written. CGS is the centimeter gram second, that is 1 gram 1 centimeter square, and 1 second minus 2. So we will be dividing both the equations. So we can say that 1 joule by 1 hour equals to 1 kg by 1 gram, that will be 1 centimeter per meter by 1 centimeter का whole square, 1 second by 1 second का whole minus 2. So it will be 1. Here we will change the denominator and numerator to a same unit, that is the CG. We have to convert it into CGS, that is 1 centimeter will be converted into, the meter will be converted into centimeter by multiplying 100. So 100 square, and 1 kg is converted to gram 1000, that is 10 to the power 3 into 10 to the power 2 and 2 4 into 1, that is 10 to the power 7. So 1 joule equals to 10 to the power 7 erg. Sorry, this will be out. 1 joule, or 1 joule equals 10 to the power 7 erg.